Yeah, like just the logic. You can control the logic using the blueprint section. Okay, so machine learning with learning agents. This is the toolkit that was introduced to our last year, and I have just few like short time to play around with it. It can be used to create AI bots. Again, this tool was used for gaming. It is introduced for gaming, not for research or this for simulations. It was created by Unreal for the people who are creating games. So we want the bots in the game to be like more human-like, not to be like bots. So that's why we introduced this plugin, and then it is also experimental, so it's not, we don't exactly trust it so far. It allows the use of reinforcement learning and imitation learning, so it is created for both of these approaches. Just a quick, very quick introduction for reinforcement learning, so that we can move forward. In reinforcement learning, we have the agent, which can be, in our case, the bus. The bus will have taken an action that will affect the environment somehow, and the environment will also affect this agent. And from the environment, we get the next state and a reward. This reward will be fed to the agent, and that's how the agent can learn by changing the policy. So the policy will get what is the state I'm in right now, and then what action it should take. And based on this reward, if it's positive or negative, it will know what action to take and how to learn. So in machine learning, with learning agents, we have 4 important components that we need to add. These are the 4 blocks here. And then we have this spline. This spline we will also show later on. The spline is just a path that we want the bus to follow. So in my case, it was just a path that I want the bus to follow. And this is, we can get values from this spline, how far the bus is from this spline. So we will help learn from what is the positive reward, what is the negative reward. So we'll take each of these components now, one by one. First of all, we have to let Unreal understand or know which object or which actor in our scene is the thing we want to apply training to. So we have to register a vehicle as an agent. So we have a bus, we can have different buses, a lot of buses in the scene, if we would like to make multiple training sessions here. We have to register the vehicles as agents. Then the manager will use these other components, the trainer, the interactor, and the policy, to train this agent that we register. So this is only the task of the manager, is that it connects between the agent and the other blocks for the training session. So we have the interactor, and from the name, this is how we interact with the environment, how the bus should interact with the environment. Here we have 2 things, the observations. So what exactly we are reading from the environment, for example, the camera data, and we have the actions, for example, steering, braking, or throttle. These are the actions that the bus can take to interact with the environment. It's important to know that all agents will share a common set of observations and actions. So if we have multiple agents in the scene, they will all have the same observations and actions. Then we have in the blocks down again in the blueprint. So here I was setting one of the observations, which is the position observation. As I mentioned, I have a spline, and from this spline we are knowing the position of the bus, how far it is from this spline. Yeah? So this is our observation in this case. I didn't use camera or anything, just the position. One of the important things here.
Are you taking the error?
Yeah.
Is that the state, or is it the observation, or the current position of a bus?
Not the current position, it's the difference between.
Difference.
Yeah. So yeah, we can set this error directly as like the reward can be negative.
Yeah, this is what I also think, that this error should be much. If you model it as a reward, it's much better.
To stay far away.
And then if you are on it, then you get a positive reward, and if you are far from
it, we are getting 0, no touch reward.
Okay.
Yeah, but if you are far away from it, we are getting negative.
Negative reward. Yeah. model as you like.
Yeah, this is how it was modeled. And then we have the scaling, because as we know, with the neural network, we need to normalize the data that we are getting. So normalize this. For example, I know that the bus shouldn't stay away from the spline with more than 100 meters per second. Then,
When you are saying spline type means you are giving some reference trajectory to that
yes,
vehicle.
so different goal points.
Yeah.
So from the scaling here, we can normalize this data. For example, the bus is 100 meters away, this would be 1. If any time in between, then it will be between 0 and 1. Here is what we are doing. We are getting, for example, here the block get agent, what agent we are using. For example, we have one bus, or we have different agents, we will have different IDs for each agent. Then we get the transformation, where the bus is exactly the same. And then here we are getting this setting observation, so it is comparing the distance between the bus and the goal point at this point. Yeah. And as you can see, this all was done on the blueprint, so not with coding, right? Okay. Then comes the policy, which is which we don't do much actually in this block. The policy is just I use the default values. But yeah, we can test different algorithms. I haven't played with them. I'm not sure what exactly other tools we can use or what other models we can use. But I just use the default values directly. And from the policy block, it is, as I mentioned, it's taking just the observations and it's seeing which actions should be taken by this. It does this by inputting the observations into a neural network, which will produce the values for the actions.
And you find any policy and a behavior for your case?
Yeah, whatever it will show.
Okay.
And the other model used was CPO.
CPO.
This is the default. Then comes the trainer. This is the more complex or the most complex block of them all, and it's just defining how the model should be trained. What's important here to define are the rewards and the completions. The rewards we know already, so so from the rewards we can define the distance as a penalty. So this is the penalty for the distance, and also I define the velocity as a reward. So if we didn't have the velocity as a reward, it can just stay on one point and it will stay in this position. It will always be 0 and it is not getting any reward. So we have to place a positive reward for higher velocities. Yeah, and the last thing is just getting a reference from the spline. This is the rewards. Then we have the completions.
So I have a question.
Yeah.
So when we are designing the reward, so there can be multiple factors that might be playing a role. For example, if the vehicle is moving, it not should only be its position added, it should be its velocity added. Like you want to reach from one origin point to the goal point with certain speed. So when you are designing rewards, we can incorporate all those factors in that.
Yeah. In my case, I just use the velocity. That if the velocity is higher, this is better. That's how it's defined. So for the rapid example, we want to have two behaviors. We want the bus to drive as fast as possible along the spline. We don't want to drive far away. Then we are talking here about the episodes, how we define the episodes in our case, and what is called the completion. So an episode is what we want to reach. We want the bus to start from a point and then reach the goal point. This is one episode. This is what we want to reach. But it doesn't, for sure, it will not happen from the beginning. So what we have to do is this idea of completions, that if we go far away from the spline, for example, too much far away, we want the episode to start again, start over. We don't want the bus to get stuck in a place and just, it will not learn anything. For example, if the bus went outside so far away from the spline, and then it came back to the spline with a high speed, then it will get positive reward by the end of the episode, and this is not good because it will not understand what was a good action and what was a bad action. It will understand that it went outside and came back, and in the end it got a positive reward, right? So we set these completions. If we go away, for example, 100 100 meters away from the spine, we want the episode to shut down and give a negative reward, a high negative reward, so that it will not do the same action later. Yeah.
And can there be some cases of instability? And by instability, I mean if a vehicle is moving on a track and it goes outside the track, or like some accidental occurrences or something like that.
This is what we define as completion. So it went away so far from the track, we want the engine to start moving. Because if we didn't do that, it can learn to
No,
come
by
back.
that, what I'm saying, that means if it goes off the track, then it can come back to the track.
Yeah.
Some event occurs that it goes off the track and it gets stuck into a point where it cannot come back to the original spline or
Yes,
reference spline.
This can happen. That's why also we have one of the applications is the time limit. So we have a time limit. After this time, if we didn't reach a good position, then it will start simulation, start the episode, and it will get negative.
Also, the approach which you just mentioned to give it a highly negative reward at, let's say, 100 units of distance when it moves away, wouldn't it still be possible for the agent to move to, let's say, 99 units, still be able to come back, and the problem would still be there? Wouldn't it be a better approach if instead of thresholding it on 100, we make it like a continuous negative reward of moving away from supplying?
So when it goes away, like now the current situation is like this. Like if it's 100 meters away, you get a negative 100 as a reward, a negative reward. Yeah. If it's between that value, we will have like we might get minus 50, minus 10, minus 5. So for the agent, it's better to have a negative, lower negative reward.
Okay, so the agent is still being rewarded negatively, but 100 is just for the episode to shut down.
And actually, also 100 is too much. Like in our case, 100 is too far away from the spline, which doesn't make sense. But yeah, it's just an example. So it can be 10 meters, or even 10 meters can be out. So yeah, here, this is setting up of the completions. So in my case, the completion was the difference in how much far away we are from this spline. Once we go too far away, it will be a completion and it will reset the agents. You can understand the logic here. Again, you are getting the agent with the IT, and then you are getting the location, then its position, the nearest point to the spline. This also can be just, as you can see, it's just a block. We don't know what's exactly inside this block, but we are getting the value we want, which is the nearest point to the spline. And then, yeah, if we are too far away, then this is off track termination. It will terminate. Then we have the learning, the trainer again, still we are in the same block. And here is just the logic behind resetting. So, okay, we will reset. What will happen when we reset? This is what's implemented here. And the idea is that when we reset, we want to place this agent into a random position in just along the spine, somewhere on the spine, or somewhere closer to the spine, and then it will start again training from this point. When the episode terminates, it will also be reset to another point of the spine. So this is the logic applied here. And again, it can look complex, but it's actually so simple that we have these three blocks are adding random values. We are getting the location. We are getting the location at a distance along the spine, any point on the spine, and then we are getting this as a point to the bus. We are adding some random value to the x and y, and also rotation, the orientation of the bus. Yeah. So we'll place the bus at any point, random point, with random position, like a range of positions away from this point, with different position and different orientation, which are selected randomly. Then we are just giving the action to set the actual transport. So the vehicle will be set at this point.
And is it always possible for the agent, because the target point for the agent might be so far away that it is not directly in its observation space. So is it always possible for the agent to make a spline all the way from its own location to the target, or does it only makes possible trajectory up to a certain point?
So
So when we talk about spline, it is basically like a reference trajectory from the agent's location to the target location, right?
Yeah.
Is it always possible for the agent to see as far as the target so that it can make a spline all the way to the target? Or is it a certain distance up to which the spline or the trajectory is being seen?
I mean, like here we are defining how much far away we can be from that point.
Yes.
Yeah, so we are setting it some very low value. We don't want to be that far away from this point. Like it's not like it can be 1 meter, 2 meters away from a point on the spine. So the spine is just a path. It can be a road. Yeah.
And is it hard coded or can it adjust along the way, seeing different dynamic obstacles? Will the spline be adjusted while the agent is
You know,
moving on?
it's fixed. So in this simulation, I didn't use even the pedestrians. I didn't add pedestrians. It was a stable and static.
Okay, so basically the objective of the agent is not to reach a target, it's the objective is to follow the spline.
Yeah, exactly. So yeah, like the logic itself, it is not that useful for me even like to run the simulation, but it is just to test the tool and see how it's working. But you can imagine, for example, if you have different pedestrians, in our case we cannot, we can get the points of the position of each pedestrian. We can get this as well. So if we want to add pedestrians to the scene, we can add this also as a reward. If we have a collision, we can know that there's a collision and we can give a negative reward. Then yeah, an important point is that we can have multiple agents with this plugin, so we can have a lot of buses in the scene, and we can all train at the same time. This can be set here, the maximum agent number. 22 is a too high value. In my case, I use just 5 different agents. Simulation crashed a lot. Managed to work. Taking level is just how often we want an action to be taken by us. So if our simulation is slow, then we need to reduce that time. Because if the simulation is slow and we are taking action every 10 times a second, this can skip, the bus can skip these actions. Right? We can give, for example, throttle value, and the simulation is not running, so this value is just lost. Just the log output. So these agents, for example, are resetting when reaching, for example, an episode when it is over. And you can see here, for example, these all reset at the same time. This can be that the time of the episode reached and it didn't reach any goal, so they all reset at the same time. Yeah. Then we have just showing that it is PPO model being used, and here we can read the average reward we are getting every episode. After training, we can do inference. So we have now a model. We need to add it to the agent. To do that, we have to stop training and remove the blocks for training, and then we can just run inference, which will get the policy that we just created. So it's just too simple, just one block we will. Now running the simulation. So again, the idea quickly is that we have a blueprint for the manager and different components will added to the blueprint. A spline was created, and this is where we are putting our observation from. Then running the simulation, a couple of agents were placed randomly along the spline. In my case, it was 5 agents. Training will start as discussed before, and then once the results are satisfied, training can stop and we can do inference. Here is what we can see. The white line is the spline. This is the spline, the environment. This is how it looks from a top-down view, and again this is the spline. So we want the bus to follow this line.
What were the green lines in the previous picture?
These are splines, not just for training. These are splines to create the environment. So this is not for training purpose. Like,
again, here also should neither visible.
this one.
Visible.
This white one is the one used for training. The other ones are splines just used for the like for example to guide this thing. Okay. Now this is when starting the simulation. We have 5 different buses. spline again, this one is over here. The spline is moving on this path. So yeah, based randomly, and you can see the orientation is also random. It is during the training, so the bus is moving along the spline, but they are a little bit far away, and also the orientation is not correct, as you can see. This is after training for around 20 minutes. And you can see again the spline is not that visible, it's flat, and the buses are starting to move on the spline. So after these 20 minutes, I stopped training, and I just used whatever model I had with the inference. And this is how this is a video for this is how it runs with inference. It is also good to notice that the steering is too much. It's doing too much steering. This also we can give a negative reward for this if you want the steering to be steering. Currently it was not, so it was steering too much. It is not avoiding distance or anything.
Because we have not trained it on the.
Yeah, so distances are just this here.
We will be under the bus.
You can see the random action that they just started running from.
You can comment on the accuracy now after 20 minutes of training. I mean, accuracy in a way, how good the behavior seems. Is there any way to find out this?
I mean, we can get the average reward and not its values, but I mean, since it is going from the start to the end point successfully, it is good enough.
Is it good enough, or you don't want to exactly follow the path of the spline that is?
Yeah, I want it to be on the path. So whatever on the path is good. Since it's going in the path, I'm not hitting any obstacles, not hitting any static objects on the way, not getting outside of the path. This was good enough.
Another is basically a completely software simulation model. Is there any hardware in loop simulation that you guys do before putting that system into the real world? Basically, I mean to say that you stimulate the actual hardware through the simulated environment and then check the triggers or actuators on the actual hardware.
Currently, so just take, if for example I want to test this, I will just take the model and run it on the real system, which is not safe.
That would be completely software-based simulation, right?
Yeah.
But you can also get the real world data also and train on both of them, huh?
The real data, yeah. So if you want to get the reward, then the reward.
Because here you are using the positions and the error. You can also have that the same thing there. But obviously you cannot afford to have to go that to afford to have this auto bus or this bus going in another path or crashing somewhere else outside the path.
And the idea in mind is to try to run this same idea, but with using images, and then we can use the images even from the real world to train.
And when you are, you were about to say?
No.
When you are training the model, because I have worked on a project for UAVs in Unity 3D. So I want to compare the two softwares. Is it possible in Unreal Engine to have multiple training episodes being run at the same time?
You mean agents or simulations? So in this case,
simulations, or you can say episodes.
we did not.
Would the episodes always be carried out sequentially, or is it possible to have multiple copies of the same environment and they are trained parallel?
I haven't tried to run different simulations, but in my case, I'm running 5 different agents. These are 5 different agents. They are training from the same simulation.
And all of these agents are training the same model.
Yeah.
It's the same thing.
Yeah. So that's it with this.
Also, one more question linked to this: do these agents see each other while they are training?
No, they are not visible. You are not using camera at all, so they are not visible. What I had to do is to just remove the collisions from this. So they don't have collision patterns now. So they can hit each other, but they don't know that they exist. Yeah, sure.
When training, like when we learn in machine learning, we learn that when you are training a model, you can do something known as early stopping. We are applying such techniques when doing the training.
Can you repeat the question?
When we are learning machine learning,
Yeah.
we say that we do not want to overfit the model. So we stop the training as soon as we see that the error starts increasing. So how do you use such techniques when training?
In my case, I just visually, when I started to see that the bus is moving in the path, I stopped. I didn't have much time to keep training more. And actually, it was crashing too much, so that's why I was happy with this validation just for this presentation. Like even this, as I mentioned, it's not what I will do in real life. I want to use the camera, I want even apply competition learning, but just for this tutorial, I wanted to get some results from this tool.
So, for example, let's take the example of the spline which you just showed. You trained it for 20 minutes, the bus starts to move on the spline. Is the bus trained on that particular spline, or will the bus follow any spline after that?
It should follow this spline.
So, will it read that?
But in this case, like it can be placed on any point on the spline. So how it goes, like it can be placed on any point on the spline, and it will follow the spline. So it's the same idea.
Since the bus is already built,
Yeah.
why do you need to use simulations? Why not take the bus and train it by using a human and then later on train by itself?
So what you mentioned is, I guess, competition learning. So we can drive a couple of times, and then we can have a model there. We can learn from that. But what I apply here is reinforcement learning. So we want to have this reward, like positive effect. We want the model to learn by itself. And if we want to do this in real life, it's risky. Like we can't just give the bus to drive around randomly. We cannot do that.
And then in the simulations, what do you add extra? Is it just an extra for aesthetics or is it needed?
Textures is for visualization, just to have something similar to the real mind. Later on, I will use camera. I don't know how good it will be without this texture. I'm not sure. I want to have this realistic environment. It looks like a real house. Because later on, I will use camera.
Even when you are adding the textures, you are saying that you are taking a few pictures, but then when the images are rotating or something, is there any time that the simulation will black out? Kind of, it will not be able to give a proper texture at any one point.
No, so currently, the texture is just images, plain images. There's no what I mean, it's not a texture, it's just an image, just visually. And if there's a place that has no image, it will just be black, white. So, like this is all here. Yeah, here. So, for example, this building, on the left, it is white because we don't have texture for this. So, it can run, the simulation can run.
So suppose this spline is for one route, and you want the bus to go on another route somewhere else on campus. So you'd have to start completely from scratch for that other route.
You can set the spline directly, and it should follow the premise.
So what if the spline's trajectory is different from the initial?
Because here the idea was not to follow a specific spline. The idea was to follow goal points. So we are feeding goal points, it will go to these goal points. This is what it is learning. Not the exact spline. If we want to teach or to train it on the exact spline, we can start from the same position always. Yeah? So we have to start from the same point every time we train. That way it will exactly follow the one spline. But what we are doing is that we are setting it on different points on the spline.
That is actually the reason why you trained it on the relative distance between the goal points instead of the actual coordinates.
Can you talk about tell us about action space in this case, or for this particular case?
So we have steering, it's maximum steering, like in our case it was a value of 3 or minus 3. Again, we make scaling so it's 1 or minus 1. But I mean,
But it's a continuous?
yeah, no, it's not continuous. No, it's not continuous. That's
Not
why you can see
continuous.
that the bus yeah, was.
No. Thing. Okay. So first of all, the steering, and is there any other action?
We have throttle, braking, and steering. And
All are
throttle has-
discrete. All are discrete action spaces.
Yeah, so even for the throttle, it's like 1, 2, 3, 4, 5, 6.
Okay.
Yeah.
If you want to make it continuous, then
If you want to make it continuous, it will just take longer. I mean,
Yes.
for
because then it would this jerking that you have may be reduced.
yeah, this is we are going to.
Because otherwise it starts going here and there, try things, okay, I can go there and then.
Like I believe the reason for this shifting movement is both that it's discrete and also that we are not giving a negative reward for steering too much.
Yeah, but he has to somehow be on the path, so it has to move, and for the agent, it thinks that, for example, the previous state, this is the best action, on the next state, it thinks that the other action is better. So if you are starting giving the negative reward, then probably it takes a bit. You are just, yeah, I think it will take a couple of negative or takes a bit of time to get back to the original thing for earlier action maybe. I think better ideas to use continuously. It will solve at least this problem, but it will be really. It takes a bit more time to train or to get to reach.
For sure longer, and I think also we can reduce the maximum steering we can have, so we don't have to take it to the full steering angle. Yeah, we can reduce the steering range.
Right.
I mean, if you want to train faster.
Yeah, but okay.
You said that we can use a Unreal Engine to do simulations directly without any code. Then why do you have to code the sensors?
For the sensors, we are using just a plugin. So, I mean, for the sensor itself, we cannot use blueprints. We have to create this sensor. It's not in Unreal itself. So this sensor models, they are not in Unreal itself. We have to create it and import it by ourselves. So it's not something that you can use directly from Unreal. Anything that you have on Unreal itself, you can do by blueprint directly.
So you have to program the C++ code as if you are using the real object and then import it in Unreal.
Can you tell a bit about how could this type of thing, or for example simulation, can be applied in for example agriculture, or for example in terms of agricultural challenges that we are having, for example crop diseases we have, or growing the crops or something in this domain. Can you relate a bit to agriculture?
Sure. So for myself, I haven't used it in agriculture yet,
Sure.
but yeah, we can check. For example, if you would like to see the yield of how much a plant grows, for example, we can simulate this. So we can start, for example, as a seed, and then this is
Okay.
an animation. Yeah.
So is it possible to also have some sort of some of these models where you have some crops, for example, let us suppose a wheat crop. Can you have this also?
Yeah, sure. You can have this. You can have different colors. If you would like to add disease or something, you can add different textures, and then you can train on this.
When you were browsing the Unity marketplace, did you happen to see any agricultural models or anything?
You can't actually, but what I used as I mentioned was, for example, assets of trees. It can be visible, like you can see a lot of these assets, different plants, different. So yeah, you should. they like. So we can change this, we can change if we want to add smoke, any all this stuff we can.
Can I simulate things like cyclones, droughts, floods?
For sure you can. I don't know how, but for sure you can.
And how did you learn about renewable energy and how to use it?
So different tutorials, just on YouTube. You take a course or something, it's just on YouTube. Yeah. Since when I started, I seriously began in college. And to make this project, I started when I do this project. Other than that, I was not in the university.
And how much time has this project taken?
Until now, like for the simulation, I took 1 month to create this simulation environment. But yeah, since then I started just to play around with the boss, see how to, because I'm also new to the group. So like tools like this sense of plugins and pedestrians, these things are new to me. So I was learning these tools as well.
So learning and at the same time implementing the requirement.
Okay, then we have a break now. Then we have another 15 minutes break, yes.
We'll start the next tutorial at 11:15.
Okay. Thank you. Thank you very much.